everyone, this is GiSO 2025 Mechanical Workshops. My name is Aisha and I'll be going over the basics for mechanical for this year's game. So a little intro into this workshop. In this presentation, we'll be talking about gear ratios, pulleys, structural integrity, as well as buoyancy.
For starters, we'll talk about gear ratios. Gears are everywhere, from bicycles to clocks. A gear ratio refers to the relationship between two connected gears and how they share force and speed. A smaller gear driving a larger gear increases the torque, and torque is force, but reduces the speed, while a larger gear driving a smaller one increases the speed but reduces the torque. For example, when you switch gears to make pedaling easier uphill, you increase the torque but move slower. Downhill, you switch to a higher speed but with less torque. Basically, higher gear ratios help lift heavier objects, but it takes more time. Lower gear ratios move things faster but require more effort. Next, we'll talk about pulleys. A pulley is a simple machine that changes the direction of force. Imagine trying to lift a heavy weight. With a pulley system, you can reduce the effort required by distributing the weight over multiple loops of rope. In a pulley system, the more loops you add, the easier it becomes to lift a load. However, keep in mind that this also means you'll need to pull the rope at a longer distance to raise the load the same height. Additionally, a pulley can change the direction of the force needed to lift the load. For example, instead of lifting upwards, you can pull downwards, making it easier to apply your strength. Now I'll talk about how gears and pulleys work together. When combined, gears provide the strength needed to lift heavy objects, while pulleys make lifting easier by reducing the force required. Together, these machines can make complex tasks much easier.
Next, we're going to be talking about structural integrity. When a beam holds weight, it either feels tension or compression. Compression is the pushing force. It squeezes a material, making it shorter or more compact. An example of this is when someone is sitting on a chair, the legs of the chairs are under compression. Tension is the pulling force. It stretches a material, making it longer or tighter. An example of this is rope is under tension when it's holding up a weight. Tying this back into beams, the top of the beam is under compression. This means it's getting squeezed by the load pushing down on it. The bottom of the beam is under tension. This part stretches because the beam bends due to the load. This is why triangles are the best shape at distributing these forces because they cannot change shape unless one of their sides changes length, which allows them to distribute both forces equally. An example of this is a square frame can easily twist or deform if you push it from one of the sides. But if you add a diagonal support, making two triangles, the frame becomes stiff and strong. That's why triangles are used in bridges, roofs, towers, and cranes. Structures don't just need to handle weight from above, they also need to survive sideway forces like wind, earthquakes, and vibrations. If a structure is too stiff, it won't be able to absorb these forces. Instead, it may crack or break because the energy has nowhere to go. An example of how this can be applied in the real world is, let's say we have a very tall building that is completely rigid. It may crack during strong wind gusts. Modern skyscrapers are designed to sway slightly so they can release that energy safely. But the structure still needs to be stiff enough to hold its shape and keep its parts connected. If a building is too flexible, beams might bend too much, walls might shift, or joints could loosen. If it is too stiff, forces like wind could cause sudden breaks. An example of this is a wooden tower with no bracings may sway too much and pull screws loose. But if it's overly rigid, strong winds could snap its supports. Using triangle bracings could provide a perfect balance. It can make it stable, strong, but not brittle. Lastly, we are going to be talking about buoyancy. When a boat floats on water, all of its weight is supported by the water that it touches. This is because the water pushes upwards with a force called buoyancy. When you place an object inside of that boat, the boat becomes heavier. But the water still has to support that weight through the same amount of contact surface. If the amount of water that the boat touches cannot support the total weight of the boat will sink. This is why increasing the boat's surface area, for example, making it wider or giving it a larger brace, can allow it to hold more weight. A larger surface area spreads the weight over more water, increasing the upward force and helping the boat stay floating even when carrying heavier weight. Thank you for watching the workshops and good luck on the games.